Hello, I'm Dr. G. Glad to meet you today at my channel. Today we again consider simplification problem. We will simplify an expression which contains square root of perfect square. I see you believe that this is a very simple problem. Probably you think in this way. We consider this square root, it is equal x minus 2. We divide over x minus 2, cancel, and we have 1 as an answer. And unfortunately, this answer is absolutely incorrect. And later you will see why it is so. Are you surprised? First, we consider outline of the solution. First, we analyze the square root, which is involved in expression. Then we write expression in traditional form. I mean, without square root and without modulus, which we meet later. We find the range of existence of the expression. And then we write the expression in simplified form, in the range of existence. I draw your attention to the third step, which is very important. However, many students ignore this, and this leads to many mistakes. We start with analysis of square root. We use definition of square root of perfect square, and this definition is as follows. Square root of a squared equal modulus a. In our case, a is equal x minus 2, so we have here this square root equal just modulus of x minus 2. I believe you remember that modulus means the same as absolute value. Now we can rewrite our expression in this form and go to analysis of modulus. Again, we use definition of modulus, which is the following. We apply this definition to our case, rewrite this equation in more simple form. So we distribute minus and rewrite these inequalities a little. And then, for convenience, we make a graphical interpretation of this answer. So what we see? We see that the number line is divided by the point x equal 2 into two parts. On the right, we have interval which includes x equal 2, and in this interval, modulus equal x minus 2. On the left, from point x equal 2, we have minus x plus 2, and this interval doesn't include x equal 2. So we see that in future we will need to consider two cases. One case which we will call case 1 will correspond to this interval, and the second case, case 2, will correspond to this interval. Let's start with the case 1, and for this case we write expression without modulus. Modulus equal x minus 2 for the case 1. Then we take right-hand side of this equation and replace modulus with x minus 2. So we have this. And here, attention, if you want to cancel right now x minus 2, you will have a wrong result. At this point, we cannot cancel x minus 2 because it can be equal to 0. And in this case, the right-hand side doesn't exist. So first, we need to consider a range of existence of our expression for case 1. How to find this range of existence? We look to our expression and we see that we have denominator which cannot be equal 0. So this inequality determines the range of existence of this expression. x minus 2 not equal to 0 means that x not equal to 2. We combine this inequality and this inequality, and we have that the x must be greater than 2. And this is a range of existence of our expression, for case 1. Now we write expression in this range. Let's do this. We replace modulus of x minus 2 with x minus 2. Now this x minus 2 and this one are not equal to 0, so we can cancel them. And we have here 1. So we have the following answer. Our expression equal 1, and this is valid for x greater than 2. So we made half a job for this time. Let's go to the case 2, and we start again with writing expression without modulus. For this case, modulus equal this expression. Then we take right hand side as we did previously. We plug in minus x plus 2 here, factor negative sign, and again we cannot cancel here for the same reason as previous. And now we analyze range of existence for case 2. Again, denominator must be not equal to 0, and it means x not equal to, and this is valid for entire interval. So we have here a range of existence coinciding with this inequality, x less than 2. We rewrite the expression in this range, and now we can cancel x minus 2, because for this interval, x minus 2 not equal to 0. And we have here negative 1. So for the case 2, we have the following answer. And we solve the second half of a job. Let's formulate the final answer. It is here. And just draw your attention that here there is no point x equal to. We eliminated this point because it is not included in the range of existence of the left-hand side of these two equations. Let's suppose we didn't do this, then we would have a wrong final answer. The difference with the right is that we have here x greater or equal to 2, but in the right answer we have x just greater than 2. Why it is not right? Let's consider left-hand side here. If we take x equal to, which is included in the interval, we have here 0, and this expression doesn't exist at x equal to. At the same time, the right-hand side is equal 1 at x equal to. So that it is incorrect, and we have here inequality, not equal. And this expression is not equal to this one. So the final answer is this one. And at the end, I would like to say that you made a great job, and see you next time. If you like this video, you may want to click like button, leave a comment, and subscribe for the channel. Also, if you have some questions or concerns, or you don't understand something, please leave a comment and I will reply later. Have a good time.